Okay, so today we're going to talk about solving linear equations. Let's keep in mind what a linear equation is. It just means that our variable is raised to the first power. The goal is to isolate the unknown. An unknown in mathematics is just the variable. That's why we assign an x, a y, a z, a k. That just means it's an unknown value that we're trying to figure out what it is. So our goal is to isolate the unknown on one side of the equation. The steps that we're going to use are really quite simple. We're going to simplify, we're going to solve, and then we're going to state. So we're going to use combining like terms and distributive property to simplify the left and the right side of the equation. We're going to use inverse operations to solve the equation. We're going to state our solution. And last but not least, we want to check our answer. Okay? So we want to simplify, solve, state, and check. That's the steps that you'll use when you're trying to solve linear equations. So let's take a look at our first problem. Here we have 27 equals 6 minus 3r. Obviously our unknown is r, so our goal is to try to isolate that on one side of the equation. As I look at my left side, 27 can't be simplified any further. And on the right side, 6 minus 3r can't be simplified. So this equation is ready to be simplified, or ready to be solved. I'm going to go ahead, and there's multiple things that you can do, but I'm going to go ahead and get rid of that 6 by subtracting 6 from both sides. Now again, why did I subtract? Because this is a positive 6. If I cover up the minus 3r, all you see is a positive 6. So I want to remove that positive 6 by subtracting 6. 27 minus 6 is 21. And I can't forget that subtraction, as we talked about last class. If there's subtraction, that means there's a negative around somewhere. And so I call this negative 3r. Now I want to remove the negative 3 from both sides. And 21 divided by 3 is negative 7. And so this would be my solution. A more formal solution set would be r equals negative 7 with the braces around it. Let's take a look at another type of problem. And there's a whole bunch of different types of equations. And your job is to basically be able to manipulate all different types. And this particular problem, as you can see, 3x plus 4 is all in the numerator over the denominator of 5. So if I wanted to get the x by itself, I've got to untangle the left side of my equation first. There's nothing left to simplify on the left or the right side. So now what I need to do is get rid of the 5. And I'm going to do that by multiplying by 5 on both sides. Okay? Now when I multiply on the left side, the 5's will reduce. And I'm going to be left with 3x plus 4. But on the right side, I'm going to distribute the 5 to both terms. Notice that the x minus 3 wasn't in parentheses. I did that when I brought the 5 over so that I would remember to distribute to both terms. And I'm going to end up with 5x minus 15. Now I have an x on both sides of the equation. Whatever you decide to do is totally up to you. However, I like to stay away from negatives, so I'm going to subtract the 3x on both sides. When I do that, this will reduce, and I'll end up with 4 is equal to 2x minus 15. Now we're back to the first equation. I'll add 15 to both sides, and I end up with 19 equaling 2x. And now divide by 2, and I end up with 19 halves equaling x. I can put a box around that to illustrate my solution, and I can write it as a solution set 19 halves. Problem number 3. In this particular problem, we have a subtraction sign in front of parentheses, which means we want to distribute a negative to both terms here. So there's going to be some simplifying that needs to be done. 6x minus x, distributing the negative through, this will become minus 4, because the opposite of adding 4 is to subtract 4. Okay, I'll say that one more time. The opposite of adding 4 is to subtract 4. Equals 5x minus 4. Now, if you wanted to go through with double angles, you could have done that. But I mean double signs, you could have done that. But I didn't want to deal with double signs. Now, cleaning up my problem, I end up with 6x minus x, which is 5x minus 4. And what I notice is that the left side of my equation is exactly like the right side of my equation. Or this is an identity. Now, we can continue to work the problem because all equations have solutions, which means even if there is no answer, or even if there's infinite answers, you still have solutions. So for example, if I add 4 to both sides, I'm going to end up with 5x is equal to 5x. And now if I divide by both sides, I end up with x equaling x. In this particular case, it doesn't matter what x equals. It will work no matter what number that you pick. So therefore, your solution set with x would just simply be all real numbers. Or as we would say, infinite solutions. Okay? So your solution set would be just all real numbers. Let's take a look at another example here where you have to distribute the negative. Again, distributing the negative to both terms, I get 3 minus x minus 5 equals 2x minus 7. Now cleaning up the left side of my equation, negative x, 3 minus 5 is negative 2. And there's my simplified form. Now I'm ready to solve. I'm going to add x to both sides. And now I'm going to add 7 to both sides. And now divide by 3. And I end up with 5/3 equals x. My solution set is just x equals 5/3. I don't want to get cute with this and change this to a decimal. Some of you would think that this is 1 2/3. That's okay. I could change this to 1 2/3. There's really no need to do that. But if you told me that the answer was 1.6 and you didn't put the bar above it, which would be the correct answer, then 1.6 would be marked wrong. Well, because 1.6 is not the same thing as 1 2/3. So please be careful. When you're dealing with fractions, just write your answer as a fraction. Now, what about solving problems that have a bunch of fractions in them? Well, what we're going to use is a method called the least common denominator. We're going to look at all 3 denominators. And we're going to find the smallest one that all 3 of these will evenly divide into. And I don't think it's very difficult to recognize that. But my least common denominator here is 12. Because 12 divided by 3 is 4. 12 divided by 4 is 3. And 12 divided by 12 is 1. So all 3 of my denominators will evenly divide into a common denominator of 12. What I'm going to do now is multiply by 12 the entire equation. And so I'm going to distribute to all of my terms in my equation. Okay? I'll clean up the math a little bit here. There you go. That looks a little bit better. And so I'm going to end up with 12 times 2/3 minus 12 times 1/4 x equals 12 times 7/12. Now let's see what happens. 12 divided by 3 is 4. 4 times 2 is 8. Minus 12 divided by 4 is 3. 3 times x is 3x equals 12 divided by 12 is 1, and 1 times 7 is 7. So as you can see, after you multiply by the least common denominator, your fractions denominators should disappear, meaning that you've accounted for them. Now I just simply solve this equation by subtracting 8 from both sides. I end up with negative 3x is equal to negative 1. Divide by negative 3. And x is going to equal positive 1/3 because you have a negative divided by negative. Again, you might need to stop the video and take a look at a couple of these examples as they're being worked on how to solve an equation using the least common denominator. My solution set again is x equals 1/3. Now I want to take a look at another type of equation solving, and that's called a literal equation. An equation that contains two or more variables. An example would be formulas. A lot of times when you're working with formulas, you want to be able to solve just for one of the variables. So your goal really hasn't changed. Your goal is to isolate the variable you're solving for on one side of the equation. So take a look at this particular. This is the way the problems will be given to you. You'll have your equation, and then there'll be a colon with a variable. That's the variable that you're solving for. Okay? So what we want to do is take this equation and solve so that u is left alone on one side of my equation. So I need to get u all alone. There's a couple of ways I could do that. I'm going to start by adding w to both sides. I'm going to get 5u equals u minus 6w. And now I'm going to subtract u from both sides. And I end up with 4u equals negative 6w. Now I still don't have u all by itself. I need to divide by 4. And I get u equals negative 6w over 4. But we should always simplify, so that would be negative 3w over 2. So therefore my solution then would be negative 3w over 2. So what I was able to do was to solve my equation for u in terms of w. That's the way that you would define this. Now there are also situations where you have to use a little bit more advanced thinking. For example, take a look at this problem. xc plus xk equals w, and we want to solve it for x. As you can see, I don't think it would take much imagination. If I was to subtract xk, I'm going to have a dilemma here with this w. So what I want to do, and this is me thinking over here, inverse operations. Well, they're not really going to help me too much in this case. So I need to start thinking a little bit more about algebra. So I start thinking about factoring. Is there something that I can factor? Because when you think about it, and when you get into algebra, right after you're done with equation solving, you usually talk about factoring. And I noticed that there is an x in common between both of these terms. So I'm now going to pull out the x. And when I do that, this is read as x times c plus k. Since it's being multiplied, I can divide by c plus k. And I end up with x equaling w over c plus k. So my solution would be I solve for x in terms of WCK. Take a look at this problem down below here as we wrap these up. I'm being asked to solve for a. So once again, I could add AC to both sides, but that's not going to get me to where I will get a by itself. So I notice that I have a times b and a times c, in which case I'm going to factor out the a because it's a common factor between the AB and the AC. Once I factor that out, I can now divide by b minus c, and I end up with a equaling k all over b minus c. So I hope that this helps. Remember, when you're solving equations, your steps are really simple. Step number 1, you want to simplify if there's any simplifying that you need to do. Then you want to use inverse operations or factoring or other techniques to solve. You want to state your solution, and then you want to check using substitution. I hope this helps you solve equations.